Hello, Assalamualaikum guys. My name is Amir, Hazim and Azam. So today me and my group going to present the project for our subject data structure. We have chosen Spotify as the apps. Spotify is a popular music streaming service that allows users to listen to millions of songs, create and manage playlists, discover new music through personalized recommendation, and stream audio content anytime, anywhere on multiple devices. So here I'm going to share with you guys the application operation, the operation that can be applied in the application, which is first is user registration and login. User create an account or sign in to access personalized content, save playlists, and synchronize their preference across devices. Next is search for music. Uh, Spotify allow user to search for songs, album, artists, or playlists using keywords to find specific audio content quickly. Next page. Next, create and manage playlists, where user can create custom playlists by adding or removing song. Playlists are internally managed using linked lists to allow easy insertion or deletion of songs. And lastly is personalized playlist features like discover weekly and daily mix playlists based on user preference. In Spotify, playlist management involves dynamically organizing and manipulating lists of tracks to create customized listening experience. The data structure used to represent playlists must efficiently support operations such as firstly is adding, removing, and reordering tracks. Next. So first, okay, the data organization and storage pattern. Efficient insertion and deletion. Users often add or remove songs at any position in the playlist. Tracks can be moved forward or backward without costly array resizing or copying. And lastly is sequential traversal. Playback proceeds forwards and sometimes backwards. So the data structure support easy forward and backward traversal. Next page. So this is the first operation that can be done in the playlist, which is insertion, where the operation here is insert new track after track two. So here track two next to new track, which is the second box, is added. Next page. As we can see here, after track two, there is a new track added. Uh, and it will continue to track 3 and track 4. Next page. This one is the second one, which is remove track. So what we are trying to do here is remove track 3. So link track 2 next to track 4 and link track 4 previous to track 2. And it will disconnect track 3. Next page. As we can see here, the track 3 is removed. Track 1, continue to track 2, and continue to track 4. Next page. So basically, this one is the third the operation, which is reorder track. What we can do in the playlist. What are we trying to do is move track 4 to position between track 1 and track 2. So it will remove track 4 from current position and insert it after track 1. Next page. Here we can see that track 1 is continued to track 4, track 2, and track 3. Next.
So the next part that we got is the algorithm and running time analysis. The selected operation for this is managing the recently played list using a stack data structure. So as we are familiar, there are several types of data structures such as stacks, obviously, which involve LIFO, last in and first out, and then we got some others which is queue, linked list, and array list. So we are gonna be focusing on the time complexity now. The overall time complexity of the class, each operation, which is play song, previous song, current song, uses stat operations like push, pop, and pick, all of which have order of one time complexity. Thus, the overall time complexity for each method in recently played class is order of one. Order of one constant time complexity, meaning order of one means that the operation takes constant time regardless of the size of the input data. This means the time it takes to complete the operation does not change as the input grows. In simple terms, an operation that runs in order of one time will take the same amount of time no matter how large the input is. It is not dependent on the size of the data. Next. So here is the step by step for the data algorithm. First, we have the initialization. An empty stack string named stack is created to store the playback history when the recently played class is initialized. Then we have the playing a song. When a user plays a song, it is added to the top of the stack using the push method. As we can see on the left side pictures, there is a comment for the push operation. This simulates adding the latest song to the recently played list. Then we got the pop operation, which is navigating back. To go back to the previous song, the top song is removed using the pop method. This mimics removing the most recently played song from the track. The last one, we have the pick operation, which represents the current song. The song at the top of the stack represents the current song that and can be accessed using pick method without removing it. Next. So we also have the operation and algorithm conclusion. So to come on a conclusion, optimal data structure, the stack is ideal for handling the recently played songs feature because it is LIFO, last in and first out structure. Naturally, it fits the way playback history works. Then we have the performance wise, core operation like play song, previous song, and current song all run in order of one time, ensuring fast and responsive user interaction. The last one we have the scalability. The stack efficiently manage a growing list of played songs without slowing down the application, making it scalable for millions of users.
Alright, so the next one I will explain about application code with the output. As you guys can see here, the at the left side, the code, and at the right side is initialization. An empty stack string named history is created when the recently play class is initialized. The stack will store the title of song that have been played. The next one, playing a song. When a user plays a new music, it is placed to the top of the stack using the push function. This emulates refreshing the recently play list with the latest current music. So the next one, navigating back. To return to the previously played song, delete the top item, the most recently played song, using the pop function. If the stack is empty, it returns the message, which is no previous song. The last one, current song. The pick function is used to determine which song is now at the top of the stack. Uh, as an example, the one being played. This will not delete the music from the stack. If there are no song, it plays no current song. So this Java application simulates a music player recently play functionality using a stack. It includes method to play a new song, So we need to push and add to the stack. So the next one, we need to go back to the previous song, pop and remove the current song. And the last one, show the current song, which is we need to check what's on top. So next. So the next one is collection class and the interface that we use. So the core data structures used is the stack under Java collection framework. So we see the class interface used in purpose. So stack A means recently play class and manage playback history. Vector E is superclass of stack resizable array used internally. List A is interface, which is indirect use that defines order collection behavior. Collection E is interface that's core collection operations. So the operation that we use is operation push E item pop pick is empty. For operation is interface class and description. Push E item pop pick is using the same as a stack, and for push E item add song to the top of stack. For pop remove and return stop song. For picks view stop song without removing, and the last one is empty. We need to check if the stack is empty. This show how data structures support real world features like song navigation. So the next one.
Okay, the last one, the conclusion and summary. Okay, so the app is based on Spotify, focusing on music search, playlist, and recently played song. Second one, linked list is used for playlist management. For example, easy to add, remove, and reorder songs. Okay, third one, stack is used for recently played. Feature is last in, first out. And the fourth one, collection class use, stack string. Next one, interface use, collection list, and iterable. The next one is main operations, uh, push, play a new song, pop, go back to the previous song, and last one, pick to view the current song. And all stack operation run in order of one, time very fast. Okay, so next one, data structures are efficient and suitable for real-time music management. And last one, the app can handle many users and songs without slowing down. Okay, so that's all from us. Thank you.